Hey, 7th graders, we are on Lesson 3, Session 2 in your books. Starts on page 53, and we are developing our understanding of proportional relationships. You already explored your understanding yesterday during the Explore lesson, which you should have done mostly on your own, and you got a fun question about kitty cats. We're going to move on from the fun questions about kitty cats into even more fun questions about gallons of water. So this table shows, it's number 1 right here, this table shows how many gallons of water Vita uses for showers at different numbers of minutes. And we're just going to look at this table and answer this question. How does the table show a proportional relationship between the length of Vita's shower and the number of gallons of water used? So, well, our unit rate is 2 gallons a minute. And does that unit rate hold up? Is 2 gallons a minute proportional to 2 minutes 4 gallons? Did they both multiply by the same amount? Yes. This is times 2 times 2. Did it hold up for 3 minutes? Times 3. Is this one times 3? Times 3. Yep, that holds up. And it's going to keep holding up. The more I'm not going to do the whole thing because these rainbows are getting pretty big here, but yes, this one is times 4 times 4 times 5 times 5 times 6 times 6. They all remain proportional all the way through. So all we need to put here is all the ratios in the table are equivalent. You may have noticed that if the unit rate here is basically, that's 1/2. This is a half, that's a half, that's a half, that's a half, and that's a half. They're all 1/2. What is the unit rate for gallons of water per minute? Well, that's right here. 2 gallons per minute. 2 gallons per minute. There we go. Remember, if I'm going too fast, just pause and think and write, and then unpause when you're ready. That's the glory of pre-recorded lessons. All right, number C here. Number C. Letter C. 1C. There we are. When ratios are equivalent, they all have the same unit rate. In a proportional relationship, the unit rate is called the constant of proportionality. I feel like that is long enough to deserve an echo. The constant of proportionality. What is the constant of proportionality for the relationship of gallons of water 2 minutes showering? Well, if it's gallons per minute, how many gallons per minute was it? It was 2. That's it. 2 gallons per minute. Use the constant of proportionality, which, if you recall, was 2, to write an equation that shows the number of gallons of water used. We're going to use G for gallons during a shower that's m minutes long. Well, what was that term we learned in lesson 1? Scale ratio. So these, you'll notice all of these are times 2. They're all times 2. Hooray! So we've got G is gallons, M is minutes. So for every minute, we've got 2 gallons. We've got times 2. So we're going to write that as an equation down here. So minutes, you take minutes, multiply it by 2 to get the gallons. No, opposite way, the way I did it. You want to take the minutes multiplied by 2 to get the gallons. Take the minutes multiplied by 2 to get the gallons. And if you recall from 6th grade, whenever you have a number and a variable touching that has an invisible multiplication sign there, it means multiplying. So we have 2 times n equals g. What is the unit rate for minutes per gallon of water? So now we're going the opposite way. We had gallons. No, wait. Let's look. We're not going the opposite way. It's trying to mess with me. 1 minute per 2 gallons. It's the same question over and over, for goodness sakes. What is the constant of proportionality for the relationship of minutes showering to gallons of water? So now we're going the opposite way. We're going minutes. So minutes to minutes of showering to gallons. So minutes to gallons. So it was gallons. We have minutes to gallons. Okay. So we're just going to do the opposite here. So for every minute, to find the minutes, you're going to have to divide the gallons in half. So you could either write that as multiplying it by 1/2, or you could do minutes is gallons divided by 2. It's just the opposite of what you had up here. Yep. Okay. Now we've got another model it. This was model it with a table. Now we're going to model it with double number lines, which is the same basic thing, really. Okay, on to gallons of paint, even more exciting than cats and water. There is a proportional relationship between the area of a wall and the amount of paint needed to cover it. And this is a legit question. You might actually you could really do all of these someday. You could calculate your shower gallon usage and your cat food. But if you ever want to paint a wall, you do need to know how many gallons you'll need. So there's a proportional relationship between the area of the wall and the amount of paint needed to cover it. What is the constant of proportionality? I'm going to highlight that pink every time because it just feels so important. Constant of proportionality for that relationship. Explain. Okay. Well, we want to look at our unit weight, remember? And our unit rate is always the per 1. So we have per 1 gallon of paint, how much wall can we cover? 400 square feet. So that makes our constant of proportionality 400. And how are we going to explain that? Because it does say explain. If it says explain, we want to be sure we explain. So I'll put a semicolon to indicate I'm going on to the next part. Let's see. The unit rate is 400 to 1, which you could write like that, or you could write it 400 to 1, or you could write it 400 to 1. All of those are the same thing. The unit rate is 400 to 1, and in a proportional relationship, I'll try to write neater, relationship, all ratios have the same unit rate. That's pretty good. That'll do. Okay. Thinking of the same problem here, use the constant of proportionality, which we determined was 400, to write an equation that represents the square feet of the wall, we're going to use W, that can be covered by G gallons. Okay, so we want to know how much wall we can cover. And in order to do that, what did we multiply the gallons by to do that? We had to multiply it by 400. So gallons times 400 will give us the amount of wall we can cover. Because remember, when the number and the variable are touching, that means multiply. 400 times the number of gallons will give us the amount of wall we can cover. Okay, let's do these two practices together, and then you're on your own for a couple of green pages here. Number 3, do the table and double the number line, and the double number line show the same constant of proportionality, and how can you tell? Okay. We've got $8 per mug. That's the unit rate for this one. So the rate, the constant of proportionality for this one is 8. Now we've got mugs cost. It's 2 to 16. Well, it doesn't give us the unit rate, does it? So we're going to have to do that math on our own. We're going to have to say 1 mug costs. Oh, look at that. If we divide by 2 to get 1, we can divide by 16 to get 8. So the constant of proportionality for the double number line is also 8. Now, how can we tell? Let's see, how can we word that? Let's do, yes, in both models, the cost in each relationship is always $8 per mug. So they have the same constant of proportionality, which is 8. There we go. That's a pretty good one. Alright, last one. We're going to use any model you like to show a proportional relationship with a constant of proportionality of 4. Any model we like. Okay, well, I'm going to do a table because I like tables better. So let's see. I'm going to make up, let's do, what did I say for my example before? We're going to say 4 ducklings per mother duck. That's ducklings per duck. So that means 8 ducklings per 2 mother ducks. And we'll even jump ahead to 16 per 4. Oh goodness sakes, this is getting bigger now. 32 per 8. And we can do 40 per 10. 400 per 100. You can go as much as you want. Or you could do, you don't have to do both of these. So I did the table model. You could also do the equation, which would be, we want ducklings to be represented by a little d, and ducks to be represented by a big D, and that would give us ducklings equals mother ducks times 4. So that would be the equation. There you go. Okay. Do your green pages, and I will see you in class.